Alright, today you're going to be proving triangles congruent. By what's called SSS, which is side, 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 and SAS, which is the abbreviation for side, angle, side. Okay, so let's get these postulates written down first. And side, side, side postulate says that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Side, side, side congruence. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So we talked about this yesterday. If you're given a couple of triangles, we'll call the one on the left MNO and the one on the right XYZ. And then let's add this information. And let's say that you are asked to determine I put an extra letter in there, didn't I? Determine whether the triangles are congruent if so, by what postulate, and write a congruent statement. Determine whether the triangles are congruent. If so, what postulate? If so, by what postulate? And write a congruent statement. So we just said that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So these two triangles are congruent. Agreed? Alright, so determine whether the triangles are congruent. We're going to say yes. If so, by what postulate? Well, we're using side, side, side postulate. And write a congruent statement. So, when we write this congruent statement, we're going to say that triangle, we can label the vertices of the first triangle in any order you want. So, I'm going to call the first triangle OMN. Triangle OMN is congruent to triangle. And here's where it gets important. If we started with vertex O in the triangle on the left, started with O went to M. So we went this direction, right? OM. We went down the side with 3 tick marks, towards the side with 1 tick mark. You have to be consistent when you're naming the second triangle. You're going to go across the side with 3 tick marks, but you have to go towards the side that has 1 tick mark. So you have to go this direction. So the description of the triangle on the right is going to be X, Z, Y. Very important. Because remember, your congruent statement has to show that corresponding parts are congruent. So the order of the vertices that you use is extremely important. You've got OM congruent to XZ. You got to have MN, alright, which has 1 tick mark, congruent to ZY, which has 1 tick mark. And ON, your first and last letters, 2 tick marks, congruent to XY, which also has 2 tick marks. So the order of your vertices is really important. That is your side congruence postulate. Any questions there? Okay, top of page 265. Triangle ABC has vertices. Triangle EFG has vertices. Graph both triangles on the same coordinate plane. Use your graph to make a conjecture as to whether the triangles are congruent. Explain your reasoning and write a logical argument using coordinate geometry to support the conjecture. What you can do in this case is exactly what they say. You can graph both triangles on the same coordinate plane. So if you've got these 2 triangles on a coordinate plane, here's our X and Y axis. We got point A is at 1, 1. Point B is at 0, 3. And point C is at 2, 5. You can connect these vertices. Alright, there's your first triangle, ABC. Second triangle. Point E is at 1, negative 1. F is at 2, negative 5. And point G is at 4, negative 4. There's point G. Now the question is, are the triangles congruent? Okay. Well, in order to use side congruence, don't you need to know the lengths of these triangles, or the lengths of the sides of the triangles? Okay. So, what do you think you have to do here to find the lengths of the sides of these triangles? Good, you can use the distance formula. Or you can use the Pythagorean theorem. Okay? If you use the Pythagorean theorem, you could use it 3 times on each triangle to determine the side lengths. So if you start right here, I'm going to start with side AB, and I'm going to turn this into a right triangle by putting in a vertical side and a horizontal side. And the length of this vertical side, it goes from 1 on the y-axis to 3 on the y-axis. So that side length is 2. This horizontal leg goes from 0 to 1. So that length is 1. See it? Alright, so to find the length of this first side, you could do 2 squared plus 1 squared equals c squared. Or instead of calling that c squared, let's call it side AB squared. So you got 4 plus 1 equals AB squared. So 5 equals AB squared. And if you square root both sides, the square root of 5 equals side AB. Then you could do the same thing for side AC. So if you put a vertical piece in and a horizontal piece, your vertical change here goes from 5 down to 1, so that side is 4. Your horizontal change goes from 1 to 2, so that side is 1. So 1 squared plus 4 squared equals AC squared. So 1 plus 16 equals AC squared. 17 equals AC squared. And if you square root both of those, then the square root of 17 equals AC. And then you're going to do the same thing for side BC. So your vertical change goes from 3 to 5, so this side is 2. Your horizontal change goes from 0 to 2, which is 2. So your side BC, 2 squared plus 2 squared equals BC squared. So 4 plus 4 equals BC squared. So 8 equals BC squared. So the square root of 8 equals BC. Then you get to do the same thing to the bottom triangle. So we're going to do side EG. We're going to turn it into a right triangle. The vertical change here goes from -1 to -4. So that side is 3. The horizontal change goes from 1 to 4. So that side is 3. So 3 squared plus 3 squared is going to equal EG squared. So 3 squared plus 3 squared is going to be 9 plus 9 is 18 equals EG squared. Did any of the top sides equal the square root of 18? They did not. So are these triangles congruent by side, side, side? Okay. So you can stop right there and you can say they're not congruent. That would just be a not congruent. Alright, flip it over a page to the bottom of 266. And we're going to cover side angle side postulate. If two sides and the included angle of one triangle are congruent to two sides, and the included angle of another triangle then the triangles are congruent. If two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. This right here is super important. This included angle. Included angle. Alright, here's what this means. If we got a triangle here, ABC, and another triangle, XYZ, and we got two sides and an included angle congruent to two sides and included angle of another triangle, then the triangles are congruent. The included angle is the angle that's formed by the two congruent sides. The included angle is the angle formed by the two congruent sides. You have to have a side, an included angle, and a side congruent to a side, an included angle, and a side for the two triangles to be congruent by side, angle, side. So there's your diagram, and here is a congruence statement for these two triangles. Again, you can call the triangle on the left. You can order the vertices any way you like. So I'm going to call it triangle CAB. And we're going to say that it's congruent to triangle. If we started with C and went to A, we started with the congruent angle and went through the one tick mark side. So we got to start at Y and go to X. And in this case, there's only one vertex left, so it's going to be vertex Z. Alright, so side, angle, side. Side, included angle, and a side. Congruent to the same of another triangle. Let me show you an example. Don't write this down, just look at it for a second. If you're given this triangle on the left and another triangle here on the right, and you get this information, let me label these ABC over here. Are these two triangles congruent? Are those two triangles congruent? This would be a case where the triangles are not congruent by side, angle, side. We said that it had to be a side, an included angle, and a side. Congruent to a side. This case right here, this angle C, this is called a non-included angle. Alright, a side, included angle, and a side congruent to a side. This angle is not included in the two sides. It's not formed by the two sides. So these two triangles would not be congruent. Okay? This angle, angle B, would have to be congruent in order to use side, angle, side in this case. Alright? Any questions on any of that stuff we covered today? Okay. Your assignment is on page 269. Problem number 8. And then on the next page, 16 through 19. (27), 28, 34 through 37. Let's make that 34 through 39. 34 through 39.